Today we're going to be talking about the GreenSeeker handheld crop sensor offered by Trimble. The features of this sensor is that it's an active light source optical sensor, so it provides its own light to be able to collect data. And the primary use of this handheld device is to measure the plant biomass or plant health of the vegetation that you have in the field. The reading that it gives you excuse me, is called an NDVI reading. That stands for Normalized Difference Vegetation Index. You simply pull the trigger when the device is over the field, and an NDVI measurement will be displayed on the screen. So what does the GreenSeeker handheld do? It's going to measure that NDVI reading based on the reflectance values from the plant. So it's using two different wavelengths of infrared of red light, a near infrared and a red, in this equation. The value of NDVI can range from 0 to 0.99, where the more green plant material there is, the healthier the plant, the higher the NDVI reading is. So the principle behind this index is that red light is going to be absorbed by chlorophyll in the plant, and near infrared light is reflected by the plant leaf. So it's all based around how much plant material is there and how green is that plant leaf. So a vigorously growing plant is going to have low red light reflectance because it's absorbing that light, and high near infrared reflectance, giving it therefore a higher NDVI value. So once you pull the trigger, the sensor is going to emit a brief burst of red and near infrared light. It measures that reflectance back and calculates the NDVI reading for you and displays it on the screen. So the primary applications of this sensor has been to estimate fertilizer, more specifically nitrogen, application rates. However, the technology can be applied in many ways to give you an indication of the plant health or variation in plant health before you can see it with your naked eye. So it's a tool to help you assess the health of your plants or of your field. That being said, you need to have some reference or some base value to compare it with across the field so that you can tell how good is good or how bad is bad, right? So the primary applications of this sensor have been used primarily in agronomic research, collecting biomass measurements, plant canopy variations, looking at nutrient response, estimating yield potential or any pest or disease impact. So any way that you want to use this sensor to assess the plant health, you have to consider what kind of crop is it and at what particular growth stage are you collecting the data to give you an indication of what those values are telling you at that point in time. You may also want to do some in-field scouting and possibly some physical data collection like tissue samples, so on and so forth, depending on what kind of features or that you're trying to assess in the crop itself, so that you have something to catalog against it while you're first learning what GreenSeeker can tell you about what's happening in the field. So like I said, the sensor has been used pretty extensively for nitrogen application. And there are a variety of algorithms for nitrogen that are available. So you can see a list here of the algorithms that we have: spring wheat, winter wheat, dryland or irrigated corn, barley, triticale, sorghum, and canola. So primarily the initial research done with this sensor was done on grass type crops. So that's where you see these algorithms come into play. It doesn't mean that it can't be used on other kinds of crops. It's just that you're going to need to do some data collection and understand at that particular point in time, at that growth stage and that crop type, what it might be telling you. Are we seeing results or effects of issues related to fertility, disease in the plant, pest, issues with pests, so on and so forth. But the whole goal is to try to assess that variation in plant health early, before we can see a problem with our eye, so that we can address it as soon as possible. So the sensor is very simple. It's easy to use. If you look here at the different options, basically you'll see that there's the LCD display that's going to display the NDVI reading. Underneath the cover is a battery that can be recharged, and then a wrist strap to help hold it so you don't risk dropping it when you're in the field. A trigger for activating the sensor, and then there's also an option there for a remote switch there that we'll go over here in just a minute. So the way that you should use the sensor, you want to hold it level over the crop canopy and pull the trigger. The optimal range that the sensor should be used at is anywhere from 24 to 48 inches or 60 to 120 centimeters above the crop canopy. So you'll take that reading and observe the NDVI value that's displayed on the screen of the sensor. If you think about the field of view, so at the proper height above the crop canopy, when it shines the red light and near infrared light down onto the plant, it's going to have an oval field of view that it's looking at on the ground. So you can see there that the variation in the size that it's looking at on the ground based on your height. So if I have it at a 24-inch or 60 centimeter level above the ground or above that crop canopy, I'm going to have about a 10-inch or 25 centimeter field of view on the ground. So the higher I am above the crop canopy, the larger field of view that I'll get. But I also want to keep in mind that proper distance from the crop canopy so that I don't get too far away. You will receive an error message on the device if you're too close or too far away, indicating that it's not able to get a good measurement of the reflectance of the light. If you want to collect data over a large area rather than just one single observation, then you have the option to hold that trigger down and walk along through the crop. Try to maintain a consistent height at all times while you're collecting that. It will take measurements for up to 60 seconds while you're holding that trigger down, and when you release the trigger, it will display then the average value of the NDVI readings for that area. And you'll notice here on the screen capture shows AVG, indicating that it's an average value for the time that you've collected data. If you just take a single sensor reading, pull the trigger one time, it will not display the AVG text on the screen. So that's a nice feature to allow you to capture some variability across an area rather than just one single observation. So if you want to use this sensor to estimate a fertilizer rate, then we need to have a reference strip that's been planted in the field. So we'll call that a nitrogen-rich strip or an N-rich strip. So that's a strip within the field that you've planted an area and have fertilized it such that any variation that we see within that reference strip is going to be due to variation in the plant based on growing conditions, soil type, so on and so forth. It's not going to be because there's a lack of nitrogen in that area. So that reference strip then is used to compare the rest of the field to. So in this case, the goal would be to bring the rest of the field to that optimal level. So in this example on this screen capture, you can see I have my reference strip, which I got a value there of 0.76. And when I go select some other locations in the field, you can see I have one location I got a value of 0.55 and another location that I got a value of 0.43. So this is going to be important as we go through the steps here to show you how you can use the chart that comes with the sensor to calculate an application rate of nitrogen. So just to reiterate, it's important that we have a nitrogen-rich strip in the field. So like I said, it's a small area in the field where more than enough fertilizer has been applied at or before planting, so that any variation is due to other outside influences, not because of a lack of fertilizer. So this nitrogen-rich strip is going to give us an accurate way to determine how much additional fertilizer is going to be required in the rest of the field to maximize our crop yield for that field. You should have a nitrogen-rich strip in each field that you're wanting to use the sensor, because each field is different and has different soil type conditions, different weather conditions, different environment that affect each respective field. So the sensor will come with a fertilizer estimation card in the box with it. This is a manual calculation process, so it's important to remember that the sensor is just displaying the data on the screen. It's not saving it in any way. You're going to need to write down this information as you collect it. If you are wanting to map out this information, then there's a variety of different solutions that you can use to collect and save that information, but those would be separate from the GreenSeeker handheld device in itself. So if you look at the card that comes with the sensor, what you're going to see is a chart that has different colored lines on it. So the first step is going to be, we need to identify what is our reference curve. So we'll go to our field, we'll go to that nitrogen-rich strip, and we'll collect an NDVI value for that strip. So in this example, I got a reading of 0.8 in my reference strip. So when I look at this chart, I follow the chart and find the line that is used, or that my data falls into, for a reference value of 0.8. And in this example, that's going to put me on that sage green line that I have circled there on the screen. So it's important to remember that this is the line that I'm going to be using in future steps. Now I need to identify my normalized rate. So I go to other areas of my field that are not in the nitrogen-rich area, and I collect the NDVI value at those locations. So I collect that NDVI value. So in this case, I got a reading of 0.6. So when I look here on my chart, I'll see here across the bottom I have NDVI on this axis and my normalized rate on this axis. So if I go to my reading of 0.6, I go vertical up to where that sage green line was. Remember, this was my reference line. And then I come over here to the left-hand side and see that it's giving me a normalized rate of 0.3. That takes us then to step 3, which is going to be identifying our crop factor. So this table on the card has a list of the different crop types. So we choose our respective crop type, in this example, winter wheat. And then we also then look at, what is my yield goal? What do I feel like my yield potential is for that particular crop? So 175 bushels is in this example. That gives me here a reading of 439. So with that normalized rate and my crop factor, then I can now calculate my fertilizer rate. So I take my normalized rate, which was 0.3, times my crop factor, which was 439. That gives me a value of 131.7. This is actual pounds of nitrogen. So I round that up to the nearest 5 to 10 pounds. So in this example, I rounded up to 135 pounds of nitrogen is required at that location. And then based on your fertilizer type that you're going to be using, you'll be able to calculate the kind of the amount of fertilizer you need to apply. So remember that your fertilizer rate is in pounds of nitrogen, and then you'll need to convert that for whatever your fertilizer source supplies. All right? So there's a whole variety of different algorithms that are available. If you look on our website, you can check that information out. But as always, you should work with your local agronomist if you need help in understanding the agronomic side of what your plants are going to need in the field versus the values that you're getting from the GreenSeeker sensor. So it's a tool to help you better manage your field. So some tips around operating the sensor. You've got to pull the trigger to start a new measurement each time. The unit will automatically turn off after you take a reading, so you don't have to worry about the batteries being run down. You've got to pull the trigger to clear the screen, so if you immediately took a reading and there's still displayed on the screen, you pull the trigger and that will begin a new measurement at any time. And like I said, that sensor is going to automatically turn off after 10 seconds if you're using the trigger. And then if you are using the remote trigger, then after 15 seconds the reading will disappear from the screen and it will turn off. All right. And most importantly, we want to try to keep the sensor level to the ground at that optimal height while we're collecting data. So there is a remote switch kit for the sensor. So as the crop gets higher, we said that optimal range was 24 to 48 inches or 60 to 120 centimeters. It can, as the crop grows, it can be hard for us to physically hold the sensor in our hand at the proper height above the canopy. So for taller canopies, I can get this remote switch kit. It includes a mounting bracket, hose clamps, and a remote switch to install the sensor on a pole to be able to have it, get it up to the proper height that you would like to have. So we simply connect the remote sense cable into the sensor, and then there's a button on that cable that will allow us to trigger the sensor, and then we'll need to lower the pole so that we can read the value on the display. So some of the most commonly asked questions about the handheld device is, does the GreenSeeker unit store those NDVI readings? No, it does not. You're going to need to write them down or use some other way of cataloging the information. The handheld is not able to communicate with any other devices, so it doesn't have any Bluetooth or anything to send readings to a mapping device. And also, what if there's no algorithm available for the crop that you're wanting to use the sensor with? Like I said, it doesn't mean that you can't use the sensor for that crop. You'll just want to work with an agronomist or a crop consultant to determine what those NDVI readings are telling you for that plant at that growth stage, and to work with to figure out what's the best way to apply the sensor to collect data and validate your recommendation. The main goal is to determine what is causing that variation in your readings. Is it fertility? Is it disease? Is it pest? So on and so forth. We do recommend that you have how much crop canopy is recommended to use the sensor. We do recommend that you have a 50% crop canopy, or so that 50% of the field of view of the sensor has plant material in it, right? Another question is, does the sensor differentiate between weeds and a crop? And no, it doesn't have any way to tell the difference. A weed has green plant material the same way that a growing plant does, so you'll need to keep that in mind if you do have weeds in that area that are captured in your field of view along with the plants themselves. And another question is, does soil affect the NDVI value? So yes, bare soil does reflect light. So the soil NDVI values, they're going to be much less than a living plant. And so this is something that you'll need to take into consideration if you are using the sensor early in the season when there is more soil present in your field of view than plant material. Okay, so our current wheat and corn algorithms that come there with the card, with the sensor, are assuming that you have at least 50% of the field of view be covered by vegetation. So again, just to keep in mind, if you're using it early when there's a lot of soil, bare soil does give you a low reading, so you'll need to make sure and differentiate. Are you seeing a low reading there because you have the plant is unhealthy, or because you have a lot of bare soil in the field of view that's causing your value to be lowered? Alright, so overall the GreenSeeker handheld sensor is very easy to use. It's a great way to get comfortable with NDVI and to learn about variation in your field and observe yourself what is causing that variability, and to help you better manage your operation and address issues within the field earlier than when you can finally see it with your naked eye.